Hello and welcome everyone. So I'll be explaining recent global round Codeforces global round problem A, problem B all together. This is the first problem named kth largest value. Actually, let me explain it. In this problem, you are come on. Okay, so kth largest value. Okay, so in this problem, you're given an array consisting of only two values, 0 and 1, and you will also be given a bunch of queries which you're going to have to answer. But the array elements consists of only two values, either 0 or 1. Now, in the query, you can ask two kinds of operations that you'll be asked. One type of operation is that um, they will say that, okay, change some of the index's value. Either if it's a 0, then convert it to 1. If it's 1, then convert it to 0. Okay, this is one type of query. I'm telling you, the elements are will be either 0 or 1. So one of the queries will ask you to okay, let's say any random index that will be given such that x, and convert its values to the opposite one, which means if it's 1, convert it to 0. If it's 0, convert it to 1. This is one type of query. The other type of query is what you have to answer it. This is what you're going to be implementing, which is the changeable query, and the other one is you're going to have to answer it, print it. What is that? That is, uh, you will be given a value k, and you have to answer what is the kth largest value available. Is it 1 or is it 0? So it's going to be one of the two values, either 0 or 1. That's obvious because there are only two types of values. So we only need to care about 0 and 1. So how did I approach this problem? I thought that, okay, if they say to me a query to change the values, I will change it according to the way they have said. If they, just like that. But when I have to print the kth largest value, I know that my my query and my array just boils down to only two categories: count of 0 and count of 1. That's all I care about, right? So initially, what I'm going to be doing is initially counting the number of zeros and the number of ones. How is that going to help me? If I somehow find out count of 0 and count of 1, I already know what is the values of this of the sorted array, right? It's going to be a bunch of zeros and then bunch of ones. So I only care about the count of 0 and count of 1, because the values will always be either 0 or 1 for the second type of query, which is going to be given as k. Okay, so if they say to me to change some values, if it was 1 and I convert it to 0, I will convert it, but I also will change one thing. What if let's say my count of 1 is some value and count of 2 is count of 0 is some value. Now if I change for some query, if they say me, okay, change some values, then if that value was previously 1, I convert it to 0, that changes this part to minus minus and this part to plus plus, obviously, because I'm adding 0 extra and deleting 1. So that's exactly what I have to do, and vice versa. Okay, for 0 for 0 to become 1, count of 1 plus plus, count of 0 minus minus. That's for the first query. I will do this operation. For the second query, what I will have to do, I have to find out what is the kth largest value. It's going to be either 0 or 1. Okay, now how I'm gonna get it? I have to in the naive approach, if you describe it in the naive approach, what would that be? I'm descending ordering the array and then finding out the kth one. But I don't need to do that, do I? Because I have the two counts. I have the count of 1, I have the count of 0. I only care about, my goal is to make the count make the value as 1 as possible, because I am actually traversing in the descending order, but I'm actually not, because I'm actually doing the same kind of operation with my count. So what I'm going to be doing, okay, instead of traversing and making the array in descending order and then traversing it and then making the complexity higher, I could do another thing. I have my count, right? What will I do? I will compare my count of 1 with k. If my k is less than or equal to count of 1, then I can assure you that yes, in my descending order array, this will be in the ones group, such that this will be then the answer 1. So then the answer would be 1. If this position k becomes greater than count of 1, which means this position is getting out of range from the group 1, the group of ones, which means this value is nothing but value 0. So that's exactly what I did. I just show you the code. Here you go. Taking n and q, and then the values, checking the count of values, count of zeros and count of ones. If it's 0, then count of 0 initially. That's the initial part. If it's 1, then count of 1. Now for each query, if it's the first type of query, I will just manipulate the array as they have said to me. According to that positions, x is the xth positioned value. I'm changing it. If it's 1, then it's 0, and then doing the operation, because if I change 1 to 0, then of course the count value changes. Count of 1 uh, uh, subtracts, and the count of 0 plus plus. Okay, similarly vice versa here. Okay, so I hope you get that. But if I get second type of query where I'm taking input as k, then the thing that I told you, exactly what I did, if k is less than or equal to uh, k is less than or equal to cnt1. That's exactly what I told you. If k is less than or equal to cnt1, then I can assure you that yes, k is inside the first count of the first groups, the first teams of group 1. So I can guarantee you that yes, the value will be 1. But if k becomes greater than cnt1, then it does not belong to the team of 1. It does belong to the team of 0. So the answer will be 0. That's exactly what we did. Easy, straightforward code, nothing complex. So let's move to problem B. So this problem, actually, if you you have to just in this problem you just have to read the statements very carefully. I did a mistake in this problem by not uh, uh, doing an attention to the constraints. Okay, I didn't make that much of attention. I didn't make that much of attention in this constraint portion here. I didn't give importance to this constraint. This is a very tricky situation because this constraint actually helped me to solve the problem. Believe it or not, but this constraint, I was trying to solve this problem, but after some moments, when I saw that constraint, which I didn't saw it earlier when I first saw the question. So this constraint is enough to solve this problem very easily. So if you didn't see it, then it might be it might have had some troublesome with you. So what is this constraint actually mean? So first of all, let me explain the problem. It is saying okay, so it's minimal cost. So in this problem, I'll define you, or I will show you how to. I didn't give much attention to the constraints. You should give attention to it when you do contest. Now, in this problem, you're given a grid type of thing, okay? But that grid will always have 10 to the power 6 plus 2 columns always. But this n, the row, this will be taken input from you, okay, by you. So this n will be, we're going to be taking an input n. This n will be referred as row, but column is always fixed. It's 10 to the power 6 plus 2. Now what they've said that you are here, initially you are here, okay, and they've also said that, okay, also one thing to notice is that n is always at least 2, okay, and n is always at least 2, and the column is always fixed, 10 to the power 6 plus 2. You have to get somehow from this part, okay, n equal to 1, I mean 1 of, and from this part to the rightmost corner, the, okay, so the diagonal corner, you have to reach here. What are the options that you can do? You cannot go in diagonal portion, but you have to go either right, left, or up or down. You can choose any direction, but there is a condition. They said that in each row there will be exactly one blockage, like this. There will be exactly one blockage, okay? There will be exactly one blockage. It doesn't matter where it is, but it will be. Now, here was the tricky part. This blockage's column number is what I didn't paid attention, because in the constraint, if you closely look at it, AI is up from 1 up to 10 to the power 6, and they have also denoted that if I denote column from 0 to 10 to the power 6 plus 1, which is totally 10 to the power 6 plus 2, and if I now pay attention here, I can say that, okay, the block won't be in the first column and the last column. Okay, that's what I was missing. But when I got that, I easily came out with a solution. So the main thing is that first column and the last column does not have any kind of blockage like this, but other columns, they do have exactly one. Sorry, the first column and the last column does not have any kind of um, blockage, and each and every row will have exactly one blockage, and the first column and the last column won't have any blockage. So the problem, also here, one of the things that you need to care about is that this U and V. Okay, U and V are coins. So this U is actually referring, if I remove one blockage from here to vertically, any position vertically, up or down, I have to use U coins. If I want to transfer one of the blockage from horizontally, then I would have to use V coins. That's what I have to do. And finally, I have to actually answer is it what is the minimum number of coins that you need to get to reach the diagonal, this part, okay, from here. And if you face any blockage, you can use the coins and remove those blockages from your path away and to get them. But all of these things actually, it's very easy to observe if you see this constraint part. So when I saw that, a solution came to my mind right away, which was that I'm about to explain. Is that okay? Now let's just explain it. Now look what I said. First column and last column does not have any kind of blockage. Okay, any kind of blockage they don't have. And what is actually bothering me here? What I only care about is my consecutive 2 rows situation, my consecutive 2 rows blockage situation. That's all I care about. How? Let me clarify this once again. If I say that I have a blockage here. Okay, let's draw grid here. Okay, let's say I have a blockage here. Okay, and then I have a blockage here. If you assume that, let's assume for now that n is equal to 2, up to 2. Okay, they don't belong here. N is, and now n is 2. I'm talking about n is 2. Now if you see that these consecutive blockages have at least one difference, one free space between them. Now if I somehow figure out that yes, two consecutive blockage have some space between them, then I don't need any kind of coins to reach my destination, because I can easily go like this. Okay, so this is one case. The other case is so I can say that, okay, that if the consecutive two blockages distance is at least 1, then my at least 2, at least 2, which means if at least 2, if their distance is at least 2, then the answer will be uh, always 0, because I won't have to use any kind of coins. But if their distance, blockage column distance, I'm only taking the column distance, okay, their column distance is equal to 1 or equal to 0. Why equal to 0? It might happen that the blockage looks something like this, two consecutive blockage. This might also happen. So we only have to care this situation, and also there's other situation which is something like this might also happen for some two consecutive rows. For these three situations, I have to care about. How am I gonna deal with these three situations? Let's explain it. If I say that my two consecutive blockages are like this, and what are the options that I can make? I can either take this puzzle or this blockage and move to here, which will cost me A plus B coins, both of the coins, row and column coins. Okay, I can transfer it here and I can move like this. This is one part. I can also make something like this. I can make I can also make something like this. I can transfer it. This blockage, I can transfer it above two positions. I mean, two positions right. Okay, I can transfer it two positions right, which means like this. There might be another free space. Then if I do that, I can get a free space like that, and I can do this. Also, there could arise another situation, something like, now for this part, how can I make it? How can I make sure? Yes, for this part, I can do two types of things. I can do this. I can make this blockage on the upside, which will cost me V coins. Sorry, U coins. Okay, U coins. I can do this. I can move it to the upside, and then I can go right away to my destination. I could also do something like this. I could make this blockage as two times right, or make this 2 times wide. Okay, so that's how I can do that. And also I have to care about, okay, for this part, if I say I could convert this blockage in the upside portion, and I could go like this. Okay, so that's all I care about. Okay, so let's take it to the code part. Okay, so there you go. So I'm taking what? And then CC and then RC. This is the column coin. This is the row coin. and taking the array and taking the values. This is actually comparing the two consecutive blockage positions difference. If it's greater than 1, which is greater than or equal to 2 actually, then the answer is 0. We know that. I'm actually comparing each and every consecutive 2, okay? So for the sake of safety, that's what I'm doing. And then if it's less than or equal to 1, then the first task is if it's equal to 0. If temp is equal to 0, this part is actually referring if the two blockages shape something like this. Okay, so for this part, what we did either it can be CC plus RC or 2 times RC. CC plus RC is meaning by if I transfer this blockage to this, okay, or this blockage to this. This is actually referring to this, and 2 times RC is actually referring to this. 2 times, just like that, okay? Then I'm just gonna go here. That's just referring to something like this. And if temp is not equal to 0, which means we know temp is equal to 1, then the answer will always be the minimum out of CC and RC. Why is that? Let me tell you once again. If they shape something like this, this is temp. If temp is equal to 1, it is referring to this type of position, this type of situation. So for this type of situation, you will deal with something like, okay, I could move it to the up, or I could move it to the left, right? Also, I could say something like this. I could move it to the up, or I could move it to the right. It doesn't matter. Or maybe this part to the left. It doesn't matter, okay? I will always get something out of it and make to define position. So that will give me two possibilities of cost, which is minimum out of CC and RC, because I have to do minimum count. I have to count when I'm finally counting the minimum out of all the coins that I'm counting. So out of all the possibilities that I'm making sure that I get to the destination point, and finally just printing the answer as a result. That's how I did that. Hope you understand that. Till next time, goodbye.